Hello and welcome to a new video using PostHog-LLM. In this video, I will do a very short analysis on toxicity using the WildChat 1 million conversational dataset. As you can see here in this graph, in these insights, the WildChat dataset was built using multiple ChatGPT versions because the data was collected for over a year between April 23 and April 24. You can see here, for example, at the start of April 23, the most popular model was ChatGPT 3.5 Turbo 0301. And overall, you can see in this graph, over time, all the models were upgraded. And for instance, here in September, the most popular model was still GP 3.5, but with another version. Now, my question for this video is, are these models by OpenAI showing more or less toxic events over time? Well, one way to see that is to calculate the toxicity rate by grabbing all the dialogues where the model has been toxic and dividing it by the total number of dialogues. So here at the top, I have my LLM task event, and this represents a single dialogue with one user input and one model output. And I will use HogQL expressions to calculate the toxicity rate, and it's very simple. So basically, I have in my clipboards, so I don't waste time, counting all the events where this property, agent toxicity, exists, and dividing by the total number of events in the data. So I will hit apply, and here you can see the trend. So very high percentage of toxic events in the earlier months, with a peak in June, for example, for both models, for any model in this time frame, and in the lower months, at the end, a much lower percentage. Now, one might argue and say maybe users are not being as toxic here in the later months compared to the earlier months, and that's why models are more toxic here in June and May. And maybe that's true. So one thing I can do instead is to plot the rate of toxicity, of user toxicity and model toxicity together, and see the evolution over time and compare them. So I'll create another series and I will duplicate this series here, and instead I want to calculate, instead of agent toxic, I'll use user toxic. It's a property that indicates if the user has been toxic or not. So it's calculating, and also it's better if I remove this breakdown so it doesn't get too confusing. And here, let's see, I can see that indeed when the user's toxicity goes up, which is the one in purple, so does the model toxicity. But you can see here in the later months, you can see there is a growing gap between the two lines, meaning that the model in blue is most likely becoming increasingly resistant to toxic behavior, so maintaining a lower toxicity rate when compared to the users. And I can, for example, calculate the difference between these two series. So I can use the formula mode here and grab the first series, A minus B, and you can see that there is a downward trend, which indicates that the gap between model toxicity and user toxicity is widening over time, with the model becoming progressively less toxic compared to the users. And that's it for this video. That's what I want to show for this video. I hope you found it interesting. Like and subscribe for more content like this, and see you.